So good afternoon, everyone. So my name is Zhu Sun, a senior research scientist at Agency for Science Research, Science, Technology and Research in Singapore. So today it's really my honor to present our reproducibility paper, an empirical analysis on multi-turn conversational recommender systems. Sorry. Okay, so many of the existing recommender systems, they evaluate the performance based on one-shot recommendation manners. That is, they use the offline, they exploit the user's offline interactions and then make recommendations without the user feedback. Despite their success, they suffer from several challenges in the real scenario recommendation. For instance, the user's preference may shift over time or can be influenced by their current demand. Therefore, conversational recommender system, the CRS, brings evolution, which enables the RS acquire users' dynamic preference and allow the users provide feedback regarding recommendations through conversation. So the CRS efforts benefits from the rapid development of the natural language processing as well as the user simulator paradigm. So the natural language understanding and generation-related studies, they always train based on the real dialogue data, which is very expensive to collect. So by contrast, the user simulator shows powerful abilities to simulate the user dialogue. In this case, we can quickly verify the effectiveness of the conversational CRS in the target scenario. So as an essential branch, the multi-turn CRS are built upon the user simulator paradigm, where the goal is to make successful recommendation in as few conversation turns as possible. However, most of the existing studies, they focus on the efficacy of the design components within the target multi-turn CRS. They are lacking, so that is to see they are lacking a comprehensive and systematic evaluation on different multi-turn CRS. So first of all, it is necessary to assess whether the components achieve positive impacts on the target multi-turn CRS. And secondly, there may be variations among different components. For example, some components may show advantages in improving the overall model performance, while other components may, have a more impact. Have more important impacts in some special scenarios. And thirdly, it is meaningful to identify the outstanding components that can work well in different application scenarios. So this inspires us to conduct a comprehensive and systematic evaluation to investigate 3 research questions. So the first one is the reproducibility. So are the design components beneficial to target multi-turn CRS? And the second one is the scenario-specific adaptability. So how does these components perform in various scenarios? And the last one is the generality. So can the effective components from the target CRS be effectively transferred to other multi-turn CRS and retaining performance that is comparable or even better than their own? So to answer these questions, so my talk will cover these 3 aspects. So first of all, we collect the data that were published in the recent 4 years on the top-tier conferences and journals. And by analyzing the papers, we identify 4 important key aspects for the multi-turn CRS. So first of all, the multi-turn CRS, they are using the users, items, as well as the attributes to do the recommendation. And there will be 2 types of relations regarding to the data. The first one is the pairwise relation. So they means they learn users' preference towards the items and attributes and modeling their embedding affinity with inner products. And the graphical relation, and this in this way, the CRS is able to capture the collaborative signals in the graph, which contains the users, items, and attributes. And regarding to the conversation module, so the main goal of the conversation module is to train conversation strategies to determine which attribute to ask and when to make the recommendations. And there are several important components here, like the state vector, the rewards, and the question manners, as well as the reinforcement learning to optimize the policy network. And regarding the recommendation module, so there will be some linear and nonlinear prediction models. And most importantly, there will be some communications between the RM and the CM. For example, the CM will provide the accepted attributes towards the RM and to reduce the item space. So there will be some information transmission and utilization. And next, let me talk about the experimental setting. So we adopted two widely used multi-turn CRS data set. One is ILP, the other is Last.fm. And three evaluation metrics are considered: the success rate, average turn, and recall. And we selected 5 representative SOTAs. Okay, and also for the training parts, there will be 2 stages. The first one is offline training, which is used to train the recommender as well as the offline policy network. And the online training is used to update the policy network by allowing the conversation module to interact with the user simulator. Okay, and then let's move to the experimental design. So regarding to the data structure, so we explore the benefits brought by the graph structure, comparing the performance of the baselines with and without the graph data. And also, the state vector can help encode different types of informations. For example, the attribute entropy, the user preference over attributes, etc. And then we will remove or add one of them to investigate their importance. And for the conversation module, for the reward setting, so there will be a number of different rewards ranging from the positive one to the negative one. And for the question manner, in total, there are 2 ways. One is to asking the attribute type, and the other is asking the attribute value. And the last part is the policy network pre-training. So we compare the performance of each baseline before and after removing the offline pre-training. And regarding to the RM part, so we consider 2 widely used recommendation backbone model, which are factorization machine and translation embedding trans E. Okay. And for the communication between RM and CM, so there are 6 strategies in total. So we study their impacts one by one. And now let's move to the experimental results. So first part is the performance comparison. So the figure here shows the performance of the baselines with and without the graph structure data. So as we can see, the performance of all models improve on all metrics by considering the graph structure data. So this is mainly because the graph structure data can effectively eliminate irrelevant attributes, making the attribute selection easier in conversation. And regarding the state vectors, so we can see that the conversation history is quite useful for making a better recommendation. And the efficiency of different state vectors varies with different models. And most importantly, encoding more information does not lead to better recommendation performance. And we also investigate the impacts of the reward. So particularly, we consider the R prevent. So that means prevent long conversation. So by considering this reward, it does not lead to a significant improvements in the recommendation accuracy, but it can help prevent long conversation. And then the next part is the comparison for different question manners. So from the results, we can see that choosing an appropriate question manner based on the specific scenario can also enhance the model performance. So this will depends on the data sets and depends on the scenarios. And regarding to the policy network, so the pre-trained policy network can boost the model performance regarding to the accuracy metrics. And the Then for different recommendation models, so through our experiments, we find out the performance of the Chen's E usually, better than the performance of factorization machine. But this advantages is weakened in the larger and sparser data sets. And lastly, regarding to the communication between RM and CM, so we noticed that the accepted attributes as well as the rejected item and attributes can improve the performance of the multi-turn CRS. And finally, let's answer the 3 research questions after comparing all the performance. So first of all, the first research question is reproducibility. So we find that the results are consistent with those reported in their papers in terms of the success rate and average turn. So this is very good. Okay, and the second one is the scenario-specific adaptability. So from the results, we can identify that using the graph structure data can help the model quickly eliminate irrelevant attributes and items, and thus achieving satisfactory recommendation results with fewer conversation turns. And partial state vector and the pre-training policy network contribute to the performance improvements, and properly selecting the recommendation model is able to improve the performance, and also for the communication, the accepted attributes and the rejected item and attributes generally have the most significant impacts on the performance. And lastly, for the generality, so in conclusion, we can see so the utilization of the graph structure data is beneficial for all baselines. And when designing the conversation manager, it is essential to consider the conversation history in the state vector, and also both the accepted attributes as well as the rejected atom attributes contribute to the performance. And lastly, let's talk about the challenges confronted by the multi-turn CRS. So first of all is the limited user interaction. So this will maybe heavily affect the performance of the multi-turn CRS. And the second is so it is very difficult to transfer the multi-turn CRS model to a new domains. And with the faster development of the large language models, so these challenges may be addressed by a large language model. So first of all, the large language models can generate a large amount of instruction data that reflect the user preference and intentions enriching the training data. And secondly, due to the generalizability of the large language model, they can help learn the universal semantics. In this case, they may be helpful in transferring multiple CRS from one domain to another. Okay, so finally, let me conclude my presentation. So first of all, we conduct a systematic review of multi-turn CRS related papers published from the recent 4 years across the top-tier conferences and journals, and we analyze and summarize important components in the multi-turn CRS across 4 key aspects. And finally, we design and conduct the experiments with the goal of answering 3 research questions: the reproducibility, scenario-specific adaptability, and the generality. Okay, so that's all for my presentation. Thanks for your attention.